Welcome back, ladies and gentlemen. Today we have with us Dr. Sarat Kumar Das, a professor in IIT Dhanbad as a keynote speaker. Dr. Sarat Kumar Das is a professor in Civil Engineering Department, Indian Institute of Technology, ISN Dhanbad, Jharkhand. His academic honors are Endeavour Research Fellowship, Government of Australia, Department of Education, Employment and Workplace Relationship for 2009 at James Cook University, Queensland, Australia. Technical Committee TC 201, members of International Society for Soil Mechanics and Foundation Engineering, geotechnical aspects of dikes and levees and shore protection for the year 2018 to 2021. Technical Committee member, Indian Roads Congress, New Delhi. Topic coordinator and session officials of 12th International Conference of International Association Computation Methods and Advancement in Geomechanics 2008. He is a theme speaker on Artificial Intelligence and Neural Network in 13th ARC of International Society for Soil Mechanics and Foundation Engineering 2007. He is a reviewer of journals for 16 numbers and 4 AC journals. He is a reviewer of book of 2 numbers as well as a reviewer of web course of NPTEL of 3 numbers. He has international publications of 55 numbers, national journals of 17 numbers, as well as 6 book chapters, and his important international conference publications are of 14. He has 2 patents filed and he has guided 6 PhD scholars, and his research and consultancy projects completed are of approximately 180 lakhs and consultancy project continuing are approximately 200 lakhs. He has been awarded for the publications. Those are International Award for the Best Journal Paper in the Unsaturated Soil Mechanics by TC 106 of International Society for Soil Mechanics and Foundation Engineering, Best Paper Award on Environmental Geotechnics, Indian Geotechnical Society 2017, Institution Award and Institution of Engineers, Odisha Chapter, Indian Geotech Society and Institution of Engineers, Odisha Chapter, Civil Engineering Division Award, Odisha Engineering Congress. This is our chief person today. Sir, it's over to you.
Good morning, everybody. So, I'm not standing here to just a keynote lecture, just I want to see. Also, I came here to see what Professor Narayan was talking about in the morning. I will just I'll tell my experience in the sustainable material. Because the term is new, coming nowadays, everybody talking about sustainability. As a student, as a faculty member, as a consultant, as also in charge of construction, I'll just have some experience and based on which I have done some research. My idea of research is just you should have a passion to do it, not to publish papers or have something. So because I find there is a difficulty, I want to solve it. Through that, if I could solve something, and that became a research that is different. So when I'm talking about this industrial waste, almost 20 years before in 1991, I reached at IIT Kanpur. My professor said, you have to work something on fly ash. 2 years before, as an undergraduate student, one field chief engineer came to teach us water resources engineering. And he told once a story that when he was the engineer of Hirakud Dam project, one of the biggest dam in the world, so that time it was a multi-purpose dam. After independence, it was the biggest one that time. They completed dam in 1954. And when they started for irrigation, some people said, you see, there are electricity they are generating. And so always there is a opposition everywhere where you go. So they said, like you take the cream out of milk, they are taking electricity out of water. So that water will not be habitable or usable for the cultivation. Never use that one. That I heard as an undergraduate student. And I reached at IIT Kanpur, he is saying me another waste. So only I had a motivation, that means nothing is a waste. Our ignorance makes it a waste. If you have knowledge, then you will have wealth. So that's why I never call anything as waste. Rather, that is our ignorance which is making it a waste. That day, when I started the fly ash, I failed in 2 interviews because I was working on fly ash. My specialization was in geotechnical foundation engineering. I went for a scientist at CRRI road research. He said, no. Fly ash is only the domain of concrete. You cannot use anywhere else. Now you see where we are using fly ash. Then another went I for a Nerist. That time Nerist was one of the CFTA. No, you have done something different out of the way, so you cannot be fit here. So I had to go back and again do something else and come back for teaching. So that way, if you do something different, you have to face this difficulty. But that is how I came in contact with a waste and how to make it a usable material. Now we are saying it is sustainable material. This is how I understand what is by sustainability. Just imagine, this is our geo-environment, which I say Mother Earth. What we are doing, we are trying to extract the minerals for which we are doing mining. While taking the mining, we are processing it. Whether we are going for thermal power plant or a steel power plant, steel plant, we are processing for industrial activity, so to get some products. In the process, we are becoming industrial byproducts. It's not a waste, because waste for one industry may be raw material for another industry. Then during mining also, all are not minerals. Some of them are coming, we are telling mine telling. All these, if they are left unattended, then it becomes unsafe for us. So that's why we are saying this is dangerous to earth, this is no waste. Because those who are using, suppose a steel plant, for them blast furnace is waste. But cemetery plant, that's a raw material. So those who are actually producing it, they are saying for them the product is important, not the byproduct. So another somebody should be there. Suppose nowadays, just a small, that's somewhere in TV channel you are saying, you are throwing that banana cover on the road. Somebody will say, I will pay you 10 rupees, 10 paisa or 50 paisa even. You give me the banana cover, chips. So that you will keep it. After taking the banana, you will have that in your pocket so that I will sell it somewhere. So that we have to understand the importance of that byproduct. That's more important. So then what we are doing, so that's why I have to process it. Because if I left unattended, it is going to create problem. So there I have to make some amendments that may be physical, chemical, biochemical, or whatever this amendment will to make it and return it to the Mother Earth as a sustainable material. That is what we are saying as a sustainable material. The sustainable material means it should not have effect on the environment. It should replace my natural resources. You see, it is helping me Mother Earth so that we should use as an alternative to sand, as an alternative to cementitious material. So that is what is my sustainable material. So for which we have to, how to process it. Because when it came to that industry, it was in a covered container maybe, or very carefully they take it to the industry. But after that, as a byproduct, they throw it in the backward so that as if it's of no use. But then somebody should be there to also with equal care to collect it. So that is what we need to do as an interface engineer. And the problem with always, civil engineers all this problem. Because as a civil engineer, you have to start it with, others will follow. Like I had one experience, I will say like just Professor Narayan was talking about this mixer. As a construction, I was in charge of my construction of the institute for almost 8 years. So once upon a time, like they said, ready mix concrete. It came, and when you take 28 days for compressive strength is important, and that strength came somewhat less, 26, 27, that less than the target strength. So I had to visit the batching plant, and at batching plant I found they are using a cement which we will never use for our own house, because we have got major plants, mini plants, they are using mini plant cements. Fly ash, we are supposed to use up to 35 code as provided, but we are providing 25, they are providing more than that. chemicals, admixtures, which you have not known. So I said, during our time, this ready-made shirt was not there, like I am getting now Van House and all this. I was going to buy Century cotton, which is reliable. The tailor may be different, but I was sure my cloth is reliable. So I want my cement should be this, my admixture should be this, and this fly ash this much percent, then give me a product that I am going to use it. Not that ready mix means everything like this shirt I don't know, I know only whether Van House or this, what is the material I don't know. So that is the problem with that. So we have to know all this when sustainable material, when I am going to develop it, what the properties I have got and what the basic thing is good in it, and that I have to use it. In the process of this, why I am also it is before, since 1940, people are working on these flyers. Slow, that time in India, like I said, 90 also, I faced this difficulty while I tried to use it in bulk. People are not using. In fact, after that I came to Bhubaneswar, there was a 4-lane project World Bank developed, World Bank aided. The consultants were one from UK, because World Bank means you have to take a consultant from outside. So UK consultant there, they wanted to use fly ash from a particular power plant. I said I have used that one, it's not feasible. They didn't believe, 92. So they sent it to IIT Delhi, they sent it to UK. Finally it came that it is not usable, but by that time they had dumped 10 trucks of fly ash to be used in the road. But ultimately it was removed. Later on now you do see in Delhi how many tons of fly ash they are using for the embankments, roads and so on. So that time that was the case. Within 25 years our concept has changed and we are changing using the fly ash like anything. These are some of the examples I am talking about here. One is your mine, coal waste, because I will tell about two, mining and industrial waste, two things. And then another is your here in Odisha, that was 31st December, to everybody was enjoying the night, that year end, New Year's, and suddenly the dam, the ash dike collapsed. We have built so many earth dams for irrigation, water resource and so on. They are not failing, but our ash dikes or ash dams are failing. So that is one. And then another one was there. This is another industrial waste, red mud. Also here it is there. So that 10 people died in Hungary. And based on this, now if you go, there may be 100 papers. People are still trying to explore on it, how to reduce its effect, that this should not be catastrophic. Then I visited some of the sites. These are all the places where I found the difficulty, then I came and gave it to the student to work on it. This is in Chhattisgarh, a power plant is there, sorry, the coal mine is there, nearby there is a power plant, you see, they are very close. They wanted to fill the fly ash in the mines, that was open cast mine. But the stipulation says maximum you can got 8% of fly ash, add to the mine overburden and dump it. So then we had to work with such laboratory investigation, then we did computer investigations in the terms of we have got now very good softwares, we can analyze. We added up to 25%, then we got approval from Director General of Mine Safety, now they are using up to 25%. So why not? Because we did it in a short term basis, why not somebody again it will explore, still we can use more. Then still I found this is a problem, lots of dust. They didn't ask for this to me, but taking a picture from there I came and I will say how we have done the research on it. This is another place nearby this. Some of the extra fly ash they were dumping at a particular place and covering it with earth. During this monsoon once, the rainwater get inflated into it and collapsed. That fly ash went to nearby cultivated land. So as I said, there are some issue, immediately there was uproar in their Chhattisgarh assembly. So they made a committee to go and investigate why it happened, how it can be prevented, how it can be stopped. So that is how I got involved with it. I just tried to find out what's the property for which it failed and how it can be prevented in future. This is another one. This is fly ash used as a reinforced earth wall. I said industrial fly ash, many people might have done it also. You see the particle size less than sand size, that silt and clay size. So they said, did the friction angle, it is around 34 degree. It can be replaced with fine sand. So they said, we'll use instead of fine sand as a material for reinforced earth. And the construction was done by L&T. The client was Vedant Aluminium. So, because they said we have got fly ash, we never sand was far off, around 70 kilometers. So, they used it. One of my students was working in L&T. After just one season, there was a tilt from both sides. He showed me in a mobile picture, sir, you see these are the tilts only, this is not very dangerous, but only the client is not agreeing to it. Please you agree that you will give a certificate. That means you will investigate and get certificate. So I, with a good faith, I agreed, okay, I will do that. Then I visited the site. The site was almost, I found lots of separation. Then I searched for the Indian code. There is no Indian standard for this. Reinforced earthwork, it is British standard BS 8005. So I went for there. I searched for the whole code. There is only one sentence. When you are using a new material, you have to check its properties and then only use it. So I had to search for the reason, because this you cannot do. You have to take help of your students to do something and do, because it's not available in the book. Why it happened immediately? Because the informations are available, but you have to compile it and find out. So these are some of the properties, and this is another one, what I was saying, Aska, that is Hungary, failure of this red mud, and what happened, that 10 people died, 123 injured, and 1017 was affected. So this has also drawn lots of attention. So we have to find out, I mean, if I can prevent it, then it can be a sustainable material and it can be usable and it is not creating problem. I said, if it is not affecting your environment, you never say it is a waste, it will be there because soil is there. It is not affecting you, so you are saying you are not using the soil also. So this is a first example I am just telling here. This is that reinforced earth, and this you see the particle, fly ash particle. Scanning electron microscope, we are talking that last 5 days we are discussing about microscopic structure. So what is the particle shape? All spherical. My sand is not spherical. So these spherical particles cannot give the same what you are expecting from sand. So then simply I said we need to amend it, because we have to use the fly ash. We have to make it sustainable, because that plant, they said, where will dump this earth and how much sand you can procure from outside, it will be very costly affair. Only I added 15% sand, you just imagine. 85% fly ash, 15% sand, and that is now this fly ash. I am talking about 2012, now it is almost 6 years. So that is what the amendment, change. There was a small change, only physical. I just made the grain size, their distribution, and that 50% aggregates, that is your say angular or subangular, all these aggregates of the sand could help to use 85% of the fly ash. Otherwise I would have said simply fly ash is not acceptable. For that I had to convince the designer from Delhi, L&T designer from Delhi. He said no, we have used, we cannot go for that, because sometimes the project helps you think differently. Then I said I am not going to tell you use 100% sand, use only 15% sand, and that is how you have to make the changes. And another case also, just out of the way, said sometimes can you use in an embankment this fly ash? Yes, but again we have to cover it. So that is how I will go for the next problem. So then During a study, we try to find out the OMC and MDD. So you are supposed to study only why it failed, how to develop it. But my research can go my different angles. I search for suppose different data. What is this OMC and MDD? From different places the flyers and see the variation, that quality control. Within 6 months or 1 year, see the OMC has changed from suppose say this is around 25 to 35. So that means when you are getting that material, you have to check it again, not that your previous senior has done that value, you got it and you use it. So that is one I said that within 6 months also this is a change in OMC MDD. So this is another aspect of this sustainable material, I mean new material. That is what BS 8005 I learned from it. When you are using new material, you have to be very careful and properly characterize it and use it. Then why it happened? I said one is the spherical. What is the other reason? So there I tried, this is the moisture content, something is just out. So this side is your UCS value for that. At each moisture content, these are the moisture content and this is the UCS value, we got it. This is based on the moisture content, like it is looking like your OMC of MDD, moisture content density curve, but is actually this y-axis is UCS, strength. What is happening? Obviously, as you said, close to OMC I am getting the maximum strength because density is high. Then what I did, simply these two samples, one I kept inside the desiccator, other I kept it